Hi, I'm Daz. On the bench today is an Ultra Transistor 6. This was given to me very kindly by an amateur radio friend. He said it was bought around about 1958, and it's an early transistor set. Old Transistor 6, well yes, it has 6 transistors in it. Off on volume, medium long wave and a tuning dial. Round the back, which I think is very interesting, is an aerial socket, and I like the way that they've made it look like it's got holes in the back of the set like you would a valve set. I guess being an early transistor set that it would perhaps they wanted it to make it look a bit more like a valve set that people were used to, but I do like that. That is very different. Let's pop the back off. I've just bought an extra light to help with the lighting, but this set is designed to work on two, I think it was AD28s, which are 4.5 volt batteries in series, and that's an interesting way of running the set. But some of the early push-pull sets did in fact seem to use 2 batteries. I've read up, and it should be possible to convert it to 9 volts by putting a coupling capacitor to the loudspeaker, so it can work like a normal push-pull. I like the early transistors in here. They seem to be what are sort of witches' hats transistors. We'll have a closer look in a minute. It's got a phase splitting transformer, but it actually does drive the loudspeaker directly. It's a 25 ohm unit, and interestingly there's a bipolar capacitor across the loudspeaker, which is interesting. Let's have a closer look at the circuit board. So it looks like it's got a very conventional on-off switch like you might find on a valve radio. It's got these interesting round IF cans which seem to be quite common in early sets. Yes, you can see the witch's hat transistors. There seems to be some screening plates here. I think that's probably to stop feedback of the IF or the audio or something. That's an interesting feature. Lots of Hunt's capacitors, and these look like Plesleys to me. Just looking along. Okay, so it's a conventional tuning capacitor. You can see the oscillator coil down there, I think, somewhere. Yes, there it is, and a trimmer. So yeah, it's an interesting looking set, isn't it? I must admit, a very interesting looking set. Okay, well, after checking the power supplies several times, I've got 2 power supplies connected up to it. I checked that positive went to the chassis, so I'm just going to switch on, see what happens. Current limits are on. Okay, drawing about 20 milliamps, and it's falling. And there's life. Excellent.
He also need more scene solution. This is basically.
That's really impressive. There's something that is so old. Yeah, older than me. 60 years old, and it's still working. Mind you, I don't suppose the capacitors are particularly in a good state, but we'll just have to see. Well, I've started disassembling the Ultra. The knobs are pull. There's a grub screw, but there's one missing from the tuning dial. 2 screws on the bottom of the chassis, and the whole chassis comes out. Everything seems to be held together by nuts and bolts, which is unusual. Got our Plessey electrolytics and a Hunt's capacitor. They're going to have to all go, but I'm going to see about if I can restuff some of them. But I'll test them first, just to see what sort of results we get. So the circuit board is fixed with those nuts, so they'll have to come off. Quite a lot of dust. Cabinet needs a bit of work. I decided it was safer to remove this bar in order to lift the circuit board up. Just going to put all the nuts and washers back so I don't lose them. They're locked, so the only thing that worries me is removing this, that the screws start to turn when I try and tighten it up. Just looking at the cabinet, it looks like whatever was on top, I assume its varnish has started to peel, but there is veneer still out underneath. So the handle, very, very tarnished. Some of this plastic has unfortunately broken off the ends. Knobs are in one piece, so yeah, a little bit of work needed on this, I'd say. So the board is free. Things to watch out. These are very, very vulnerable, these connections here. Don't breathe on it. There is a crack here. I'll just get it in the light so you can see. Transistors are by Eddie Swan, if I've got that right. Let's see if we can get a close-up. I'm not sure how far I can go in. If I start to lose focus, about there. Okay, so yeah, you can see there, Eddie Swan transistors. The output transistors appear to be silver. Now, one thing I've noticed is we're missing a screw out of the capacitor. These have perished, so I might have to see if I can replace those. Let's just come out a little bit. There we go. Just see the PCB. It's the wave change switch mechanism. Potentiometer. Okay, we said we'd have a look at some electrolytics. This is a 6 volt 10 microfarad. 14 microfarad, the ESR is 14 ohm, that is quite high. It's the AGC, probably 14 ohms wouldn't make a lot of odds really, because it's a AGC capacitor, but it's when we get to the decoupling ones. Right, well I'm going to go for restuffing again. Cat hair. So I've cut round the ring again and pulled it apart. I've got a capacitor to restuff, it should fit. Axle capacitors are not cheap and they're getting harder to get hold of now. So I'll just do exactly what I did last time with the restuffing. Well, there we go. There's the completed unit and the rivets I unglued. Hard to get the focus when I'm this close, but there we go. So I just come out, let's have a look what the modern capacitor looks like. Very close, low ESR, very low ESR. Good. Hopefully the lead will bend round and be long enough. Here's a larger Plessy. This one's 50 microfarad. Let's see what happens with this one. In circuit leaky, no capacitance reading at all. Okay, so it was wise to restuff these, most certainly. Well, part way through, I've decided to try and put labels around the capacitors I've replaced in the Hunts. I just don't like the yellow. Capacitors look alright. So I'm getting there. Not quite there yet, but I sort of thought to myself, am I totally mad doing this? But no, I think it looks nice, retaining some of the original look. I know I can't make it fully original, but you need components that are not leaking or likely to split and absorb moisture, so I think it's a good compromise here. Well, at least it still works. after the recap, so that's good news. At the moment I'm just experimenting with a single supply. I've got a 470 microfarad capacitor in series with the speaker down to positive. The results seem good so far. The interesting thing I'm just thinking about is why they used a 4 microfarad across the speaker. I don't know. Let's turn that off. So why did they use 4 microfarad? I reckon it's for stability, because most push-pull circuits I see have got something like about a 3 or 4 nuff across between the two bases of the transistors. This doesn't have that. So when you disconnect the capacitor, it starts to squeal and go off on one. So I'm wondering if that's a different method of getting stability or stopping oscillation. Interesting. Doesn't like that, does it? Capacitor is on. It becomes very unstable. I've taken the capacitor off the speaker and put a 2.7 nanofarad between the bases of the 2 output transistors, and it seems to have disappeared. I'll put this capacitor on and see if that feedback disappears when I turn it off. It does. So my mod is not perfect, but it seems to have stopped the output stage oscillating, which is what I think the 4 microfarad is for. I tried 2.7 enough, and it sometimes fed back, doubled that up, so I had 5, and it was just on the edge. So I've put 10 in, and I daren't go any higher than that, because that's going to start to probably do strange things to the push-pull. But I've got no instability without the capacitor across the speaker now. It just seems to be, stable. Okay, looking good. I've replaced the biasing resistors, the output stage, because it was sitting at 5.5 volts. Should really be sitting at 4.5 on the push-pull, and it is more or less now. With these resistors replaced, one of them was really high and one was lower than normal, so it was completely unbalancing the transistors, but these appear to be still balanced well. You can see there's an extra capacitor here now. I've removed the center point for the battery and put an electrolytic in its place, and I think it would be easier if I probably drew a circuit diagram so that you can understand what I've done there. But at least now it means it can run off 1 PP9 battery, although I'm not quite sure how that's going to fit in the radio, but I'm sure we'll come up with something. Right, well, I've redrawn the push-pull circuit here. You can see the driver and the output stage run directly off the battery, and the rest of the stages via a decoupled supply formed this 270, and there's 100 microfarad here, which I didn't write in, which I will now. There we go. So the idea was it ran on 2 4.5 volt batteries, so you'd have a battery between here and here and a battery between here and here, and then each transistor will switch into each half of the each battery. It would use each battery for each transistor effectively. So with a bit of luck, if both batteries are good, it would be perfectly balanced and there would be no DC in this speaker here. What we did find is that the biasing resistors were out a little bit. This one had risen to 195, so this transistor was switched on a lot harder. So instead of having 4.5 volts here, I had 5.25, so that would have put DC in the speaker and increased the battery consumption. But what I've done instead is I fitted a capacitor here down to positive, and that now means we don't need to use 2 batteries anymore. So I've used a 470 microfarad, so that should pass the base easily. I could probably have got away with something smaller than that, to be honest, because it's a I think it's a 25 ohm speaker. So yes, 25 ohm speaker, so I probably didn't need to. So that's the mod I've made. But it's always a good idea to check these resistors. In a circuit like this, it should really be sitting about halfway. If you're sitting too high up, you're going to clip on the positives, so it means that your maximum volume you're going to get is going to drop. So it is a good idea just to check these like I did, and as I said, that one had really shifted. You'd hope that resistors of the same value would of the same batch would drift the same way, but it's obvious no, they're not. I've even found some resistors that have drifted down in here. I need to check that one as well when I've got a moment. But anyway, that's just a little bit of a sketch to help understand what I've been doing to the set and how I've been modifying it. Oh, that reminds me, the capacitor you saw me putting on earlier is here between the two bases, and I was just trying 10 nuff there, and that seems to have the same effect as this capacitor here that's across the speaker, the 4 microfarad, which I forgot to draw in. I think it is a way of getting stability, so I think it works the same way as that. Perhaps somebody else will comment if they've had any experience with that. But yeah, what I did is I had to use 2 10 microfarads back to back because I don't have a reversible capacitor to hand, but it seems to work all right, no problems. Though I was getting a squeaking noise this morning, and that ended up being the battery pack I was using on my phone to charge it. You learn these things, don't you? Okay, I'm just looking at this as far as alignment is concerned. This has an unusual frequency of 471 kilohertz for the IF. Here are the IF cores. I can move them, but I'm going to have to be very, very careful. They tend to be brittle at this age. Aerial tuning coil here. 2 capacitors on the tuning cap for trimming the high end, local oscillator and aerial trimming. And there's another trimmer here for long wave, which I believe is only the local oscillator. The instructions I'm reading have got me slightly puzzled because they're referring to this as the medium wave coil, but as far as I know that is the coupling coil for the aerial input. Oh yes. How interesting. It's actually a TV aerial socket for the aerial it fits, so it must be what it is. How odd. So it also calls for injecting the local oscillator via a coupling aerial rather than directly into the set, so that's a secondary interesting thing. And of course it says the usual thing, don't go over 1 volt because you're activating the AGEC then, I guess. Give this a little tweak. Oh, that's very, very sharp, isn't it? Not much improvement here. That's what I suspected, so that's pretty well accurate. Now going for the RF tuning, 600 kilohertz, 500 meters. So this is the local oscillator coil. Now at 200 meters, 1.5 meg, so this one first. Just trying to find me tone. Oh, there it is. Far too high. Don't you love it when you get a beat tone on your desk? Well, that seems to come up a little bit, but not a lot. Now back to 600 kilohertz. I'm just readjusting it. There we go. Well, I've repeated 1.5 meg and 600 kilohertz a few times. I've got a little bit of improvement, but not a lot. This strange noise that beats with it at 1500 kilohertz or 1.5 meg is a bit weird, but there we go. Little bit out on the long wave, but back that off. I could tell the fact I was receiving radio 4 that far back, but right, well, I'm just about ready to put the back on. Here's the PP9 now. That's a little bit of extra wood just glued in here, just to hold the battery steady. So I think I'm ready to go and give it a test. Just hold it up a bit so the light's better. So there we go. Okay, I've got a bit of yellow showing, but it matches the Plessy, doesn't it? So it looks alright, I think. And the case is looking a lot better now. Well, there she is, back together. Handle's not perfect, couldn't get all the marks off the front, but she's a good performer, I must admit.
Bennett and Dean Martin.
I can hear RTE
Sorry, you're just...
on long wave, so that's good. And she does get Caroline.
8. Proof that...
Right, this is Motorbike from the YouTube library. That's an email message. That's the Ultra Transistor 6 or TR100. It's a nice radio from 1958. The Eddie Swan transistors are obviously still good, so didn't have to replace any transistors this time, so that's good stuff. Anyway, I quite enjoyed doing that one and making the labels up for the capacitors, etc., to try and make it look interesting and similar to what it used to be. Anyway, thanks for watching, and I hope you enjoyed the video, and I'll see you soon.